Factors that control metamorphism. First, the main factors of metamorphism are the parent rock and the physical conditions. Um, the most important factors in metamorphism are the chemistry of the parent rock and the physical conditions which make up the rock. Physical conditions are also known as agents of metamorphism, and those agents of metamorphism are heat, pressure, and the circulation of fluids. Time also plays a very important role in metamorphism, although it's not a factor of the actual physical agent of metamorphism, but it is a big factor. Together, all of those work together and they break down bonds in unstable minerals. They promote mineral growth, and they also fuse reactions and make them faster in breakdown of rocks. A big difference between the parent rock and metamorphic rocks are it depends on the metamorphic grade, and the metamorphic grade is known as the measure of intensity of metamorphism. So, like, which an example, the way that the rocks are acting on one another. Reactions occur faster the farther down in Earth's crust that you go. For example, Earth's crust, like the picture 1 or 2A, as you can see, the heat is coming from the center of the Earth and it's going outward. So the farther down, for example, like country rock compared to a rock below it, the rock below it is acted more on by the heat, and so that's the factor of metamorphism, and um, the heat's reacting on the rock the farther down in Earth's crust it goes. An example would be it's called the geothermal gradient, and which by definition it says that, or the definition is for every mile towards Earth's surface, the temperature increases 60 to 100 degrees Fahrenheit. An example of that would be picture A. So heat. Heat, as most of you would know, heat flows from a higher concentration to a lower. So it would, like, basically if it's next to a cooler rock, it's going to want to flow into that rock and make it hotter. It also flows from the interior, which means it also flows from the interior to the exterior, like the core, which you can see in the picture on the right. Another example is heat is also transported through the flow of magma on Earth. What does heat do to rocks? Heat speeds up the reactions of rocks, and when rocks become warmer, the vibrations of ions become more and more violent and they collide with each other, like moving faster and faster. By that, the rock begins to increase; it expands because of the heat, and there's a lot of stress on the bonds within the rock. Once the mineral expands, more distance, there's a greater distance between the ions, and then with that, when the rock is at a high stress, when you add more heat to the rock, bonds begin to break, and then that forms new minerals with more open crystal structures in the rock. So the rock's almost like changing its style to become like a new, to like fit the higher heat conditions of where it's located. If it's getting like deeper down into the Earth's core where it's hotter. But if all of the bonds break in the rock, then it turns into magma. And then for the typical melting range of a rock is between 1,300 and 2,200 degrees Fahrenheit. Next slide is the pressure. So there are two types of pressure. But first, to talk about pressure, pressure is defined as by the book as the force pressure on a unit area of rock. It's opposite to heat in that heat, like I just said, expands rocks, and pressure causes rocks to decrease and like become a lot tighter and smaller. So the two types, there's or yeah, no, there's confining and directed. Confining is like an equilibrium where everything on the rock would be completely pushing at it in all equal ways, and then um, directed pressure is where it's like more, it's kind of how it sounds. There's more direct in one way and not the other. Um, so in better detail, confining pressure is like vertical pressure exerted on rocks because, as you can see in Figure A, there's pressure pushing down, and so the lower rocks are, the more pressure is pushing down on them, and there's pressure pushing up to keep them, because if there's no pressure pushing up, they would just keep going down. There's also horizontal pressure that pushes on the rocks. Um, the farther down it goes, the horizontal pressure gets greater as well. Um, the increase in pressure causes the rocks to like compress and contract. It compresses the ions in the crystals, pushing them together. They take place because the rock is becoming, like I said earlier, in heat. They're always just trying to find like an equilibrium and like just conform to a better state, and so they compress to. Um, so by compressing, it causes the ions to be more closer together, and by that it's making a denser mineral. It's more stable, and it also only so the confining pressure is volume based, and then directed pressure is, as I said, acts more on one side than the other, um, and then it occurs near like faults or plate boundaries where there's like, and like a lot of shear rock would be moving. The shear rock grinds down the texture of the rock and also the edges of the rock to, which changes it. Directed pressure also changes the shape of the rock because it's unequal pressure. So confining would just squeeze it down, but directed could push in like one side of it. Um, so as you can see in Figure A, it's an example. It's a diagram of pressure where heat and pressure pushing up and out and all around. B is an example of how you can see like the compression of rock, and you can see the layering just kind of morph together and turn into the new change in rock. Next, we have fluids. The picture on the right is just all these rocks underwater, and I'll talk about what rocks underwater means. So fluids, fluids cause ions and atoms in the rock to migrate all around quicker. And like I said in the first slide, that was like introduction to the rocks. It's like rocks can grow, even though it doesn't sound like it. They don't just like grow by. That sounds weird, but the fluids help move the ions around to parts of rocks, and it increases the rate of metamorphism because you're like speeding up the reactions. Water is the number one most common fluid used in fluid that's in rocks. Carbon dioxide is also another very important factor with the fluid that influences how the metamorphic rates and reactions occur in the rocks. So fluids can be like, where can you find fluids, or like how can they get in rocks? They can be trapped in rocks at the forming of them. They can be introduced by the tectonic process when with the convergent divergent shear plate boundaries, the movement of the plates. They can allow fluids in the rocks, or they can also be from the crystal structures from the metamorphic rocks where they like change and they metamorphosize into, and the water's already there. Water also has a very high capacity for storing heat. So when you mix the water with high like H2O content or other fluids, but specifically water here, you can so the rock is more down and towards the core with heat reacting on it, and there's presence of fluids. It's going to have a higher impact because it's going to store the heat more, and by storing the heat more, it's going to have a greater reaction with the heat metamorphism as well as the fluids. So that'll break down the rock even quicker, making it more susceptible to metamorphism. next, the rock composition. um, so rock composition is there's many like ways to it, but the main talk of rock composition is like obviously what it's comprised of, which is the parent rock, which sounds I guess kind of weird, but the parent rock is like the main reason for the minerals that are in the metamorphism rock, because a parent rock doesn't just like create another rock; it's just the parent rock is transformed into the new rock. So that's how it gets its like minerals, because it doesn't just like completely change and start over. Uh, but all factors of metamorphism, um, when they all act on rocks, it's not just heat or just pressure or whatnot. It's they all are pushing on each other, all acting with each other, um, to help metamorphosize rocks. Um, rocks. The tricky thing about it is, um, when they work together, if the same exact pressure and heat and temperature, like all that, all work on one rock and a different parent rock at the same time, they're going to produce different rocks because they're mineral composition, but because of the different parent rocks, they're different rocks. However, in contrast, there's also like um, a little bit like, so there's, but an example of that would be, I know basaltic or basalt, yeah, basaltic rock produces hornblende, and then under like with really similar conditions, but like so the same conditions, but almost like you can't have it exactly, but a different parent rock. The same areas, mudstones produce kyanite, so it's like that's how there's an example. Another thing that's weird is um, the same pressure, like the same fluids, but different temperature with like the heat can also just change the way that the parent rock would change because of a small factor of metamorphism like that. Next slide. Okay, time. So time wasn't known as it's a big factor, but it wasn't an agent. So an example is, um, however, it's very underlooked, but in my opinion, it's the most important because um, all the factors that I talked about before time all like act on the rock, but without time, then nothing happens on the rock. And this is all this talk that I've said is all like sped up, but it's a lot. Um, it's over a long period of time, and that's the reason how they can metamorphosize. Um, with time, rocks are adjusting to a state of equilibrium around them to better fit in their environments. With pressure, they decrease, and heat they expand because it just works out better for what the state that they're in. Um, so heat and like fluids all react on the rock, but without time, nothing's reacting on them. And um, like I said earlier, time's important because there's different times for different like factors of metamorphism. Because if it's on the crust, as you can see in Figure A, the outermost layer of the Earth, it's going to take a longer time. But the mantle and then the outer core, and even like the lower it goes, the rock process of metamorphism will speed up greatly because of the increased heat, and so time decreases with that. And then other changes that we haven't talked about but are still in effect with metamorphism. Um, there's so other things that will happen with metamorphism are the um, is change increase in the crystal size. Um, Minerals start to layer, as you can see in Figure B, where the pressure and all the conformed, like the rock conforming, there just starts to layer, and you can see how pressure would form that. Crystals can deform, and they can get smaller and shrink, as you can see in A. You can see the crystals in that rock. But also new minerals form from changing ions and atoms, and they so with factors of metamorphism they change, and you can see a difference in the rocks. So